Humans have now been defeated by computers at heads-up, no-limit holdem poker. Some people thought that this wouldn't be possible. Sure, we can teach a computer to beat a human at Go or chess. Those games have a smaller decision space. There's no hidden information. There's no bluffing. Poker must be different. It's too human to be automated. The game space of poker is different than that of Go. It has 10 to the 160 different situations, which is more than the number of atoms in the universe, and the game space keeps getting bigger as the stack sizes of the two competitors gets bigger. But it's still possible for a computer to beat a human at calculating game theory optimal decisions. If you approach the problem correctly, that is. Libratus was developed by CMU professor Tuomas Sandholm, along with my guest today, Noam Brown. The Libratus team taught their AI the rules of poker, and they gave it a reward function, which was win as much money as possible, and then they just told it to optimize that reward function. And then they just had Libratus train itself with simulation after simulation after simulation, and after enough training, Libratus was ready to crush human competitors, which it did in hilarious and entertaining fashion. There's a video from Engadget on YouTube, which I linked to in the show notes, and it shows the AI competing against professional humans and just destroying them. It's really entertaining. In this episode, Noam Brown explains how they built Libratus and what it means for poker players and what the implications are for humanity. Because if we can automate poker, what can't we automate? Flip the traditional job search and let Indeed Prime work for you while you're busy with other engineering work or coding your side project. Upload your resume and in one click gain immediate exposure to companies like Facebook, Uber, and Dropbox. Interested employers will reach out to you within 1 week with salary, position, and equity up front. Don't let applying for jobs become a full-time job itself. With Indeed Prime, jobs come to you. The average software developer gets 5 employer contacts and an average salary offer of $125,000. Indeed Prime is 100% free for candidates. No strings attached. Sign up now at Indeed.com/SEDaily. Thanks to Indeed Prime for being a loyal sponsor of Software Engineering Daily. It is only with the continued support of sponsors such as yourself that we're able to produce this kind of content on a regular basis. Noam Brown is a researcher at Carnegie Mellon University. Noam, welcome to Software Engineering Daily.
Oh, thank you for having me.
I want to start off by giving you and the listeners some quick context on my own background in poker, because the work that you're doing on Libratus, the poker AI, is really close to my heart, because when I was in high school, I was playing poker, and then early on in college, I was playing in some high-stakes games online. This was back in 2007 when the games were really easy. And then there was some legislation that made it really hard for people to put money online, so the competition got a lot harder because the people who were fishy were not putting money online anymore, and just it became a competition of really good players. And around that time, I started losing because I was not as disciplined, I was not as creative, my play was too algorithmic, and all of the best players were more flexible, they were less emotional. So eventually I just decided to quit and focus on school, which led me to computer science, which brings us to today. Libratus is this poker AI that you've worked on, and Libratus is effectively more creative, more disciplined, and more thorough in its exploration of the game space of poker than any human has ever been. And I know this is going to be hard for professional human poker players because their time has come to pass. Like, they are no longer viable poker players compared to automation. They've been automated away before even the truck drivers. Why is it that poker is so much easier to automate than people want to believe?
Yeah, you bring up a really good point. I think when I tell people that I'm working on AIs for imperfect information games and applying it to poker, one of the things that I hear really frequently is, well, how can an AI learn to bluff like a human can? They have this idea that bluffing is this very human behavior that an AI can't emulate. And the reality is that this bluffing behavior and really the entire strategy of poker is a very mathematical process, and you can arrive at a really good strategy for poker. In fact, a perfect strategy for two-player heads up, which is what we're playing. You can arrive at close to a perfect strategy using complex computer science algorithms. But certainly this is not easy. In fact, it's a lot harder than a game like chess or Go, and so I think people are right that this is not an easy process for an AI, and that there is something far more difficult for an AI to emulate human behavior when it comes to poker. But this is certainly within the realm of possibility for an AI. And I think this really highlights what we're seeing in AI in general. I think people have this idea that there are certain things a computer is good at and certain things that a human is good at. For a lot of these tasks, I think they categorize those incorrectly. So, people used to think that an AI could never play chess or that it could never play Go. And, until very recently, people thought that an AI could not master poker. And we're seeing that those are all actually tasks that a computer can master to a greater extent than any human can.
Speaking of people framing problems incorrectly, I think this whole framing of imperfect information games versus perfect information games doesn't make a whole lot of sense, because an imperfect information game that is well-formed, it's got a probability distribution that you can map out accurately. Isn't that computationally equivalent to a perfect information game with just a very large game space?
So actually, no. When you introduce this uncertainty element, this hidden information component, the game actually becomes much more difficult to play than a perfect information game like chess or Go. And for the listeners, I should clarify, but what I mean by imperfect information is this component of the game where you don't know exactly what's going on, or your opponent doesn't know exactly what's going on. So in a perfect information game like chess or Go, both players know exactly what's going on at all times. They can see all the pieces on the board. But in an imperfect information game like poker, you have your cards that only you can see, and your opponent has their cards which only they can see. So you never know exactly what's going on. You never know exactly what state of the game you're in. And the problem there is, go ahead.
Well, I was going to say, you don't know exactly what they have, but you can say, okay, there is a 1 in 52 chance that they have a ace of clubs in their hand, and there's an 18% chance that they have 2 clubs in their hand, and you can make all of these probabilistic statements that are going to be accurate. And once if you have all those probabilities mapped out, then it might as well be a perfect information game.
Well, you're going to be correct at the very beginning of the game, right? So there is a 1 in 52 chance that their left card is a 2 of clubs, and 1 in 52 chance that their right card is a 5 of spades. But as soon as they start taking actions, then those probabilities change. And the way those probabilities change is entirely up to them, right? Because they determine their own strategy. We can't make assumptions about how they're going to play. So, you're a poker player. Let me give you an example, all right? Let's say you sit down at a poker table, heads up against this player. You have like 200 big blinds deep, so you have a lot of money in front of you. Let's say you have $20,000 in front of you, and the blinds are $1, $2. So you get your hand, and the very first action of the game, before you've ever seen this guy play before, the first thing he does is bet all in. Now, what's the probability that he has each hand? You tell me. Do you have any ideas here?
Right. Right. I see what you're saying.
You can't make any. You can't assume that he has pocket aces, because then you're only going to call with pocket aces, and then he'll try to bluff you. So you can't do this reasoning of there is a certain probability that he has each hand, and here are the probabilities. The process is far more complex than that. And the correct answer of how to approach this is that you have to consider the strategy for the entire game as a whole. That's why imperfect information is so much more difficult, because you cannot look at a situation in isolation. If I told you that, this guy just bet all his chips, he went all in, and I ask you what's the right thing to do, well, that really depends on how much money he could have made for each hand by not betting all in, by playing normally. So when you play these imperfect information games, you can't look at a sub-game in isolation like you can with chess or Go. With chess, I can just show you a chessboard halfway through the game, or I can show you where there's one move to checkmate, and you can play it out from there, not having to know much of the strategy of chess. But in poker, it's different. In fact, in poker, as you get farther into the hand, it actually becomes harder to play, both for a computer and for a human, because there's so much more uncertainty. There's so many more hypothetical situations that might have come up, and you have to consider all of that when you're forming your strategy.
So this is basically the meta game that you're describing.
You could think of it as a metagame, but I see it as really the game itself. I see this as really the essence of what poker is. Trying to come up with a good strategy for the entire game that your opponent can't take advantage of.
So the people who have worked on Go or chess, my understanding of those games, I mean, it's not great, but is that the game space is still too big to model completely, so they have to use some heuristics. And so, like, yes, these are, in a sense, perfect information games, but since you can't traverse the entire decision tree, you have to use some form of heuristics. It seems to me that the processing of a given decision is somewhat similar to the processing of a decision even in an imperfect information game where you're using some heuristic. The only difference is the heuristic in an imperfect information game is, what has this player done in the past, perhaps, and how am I using that to traverse the information, whereas in a game like Go, a perfect information, you can just trim off branches really quickly where you can say, okay, this branch doesn't make any sense.
Actually, the approach that we use for imperfect information games is, I would say, pretty radically different from the approach that has been used in perfect information games like chess or Go.
Okay.
The approaches that are used in chess and Go all function on this idea of searching through the game tree. Right? You're in a certain situation, you're in that situation, and you search for as far as you can, and then eventually the game, there's too many possibilities to consider, so you just use a heuristic to decide what's the value of this state that I've reached in my search. So humans sort of do the same thing when they're playing chess, right? We say like, oh, you can look 3 moves ahead. So they look 3 moves ahead for all the different possibilities, and once they get 3 moves into the future, they're like, well, this situation looks pretty good, or this situation looks pretty bad, based on some heuristic of the game board. And with poker, that approach doesn't work, and you really have to start from scratch with an entirely new approach. So we do, really the essence of what we do in poker to come up with a good strategy is reinforcement learning. It's this idea of the AI learns how to play on its own. It starts completely from scratch, playing completely at random, and then it just plays itself in trillions of hands of poker. And over time, when it finishes a hand, it goes back and reviews all of the decisions that it made. And it asks, if I had done this other action instead, would I have gotten more money? So, and humans do this too, right? When humans are playing poker, after a hand is over, they'll ask their friends, well, if I had raised there, would you have called me? And the AI is doing exactly that on every hand. And if the answer was yes, you would have gotten more money, then the AI will take that action more in the future. So this process, over these trillions of hands, the AI gradually improves in a way that's pretty similar to how a human improves. And eventually it arrives at what's called the Nash equilibrium. This is a perfect strategy in 2-player poker. Poker players might be familiar with this term more as game theory optimal, GTO.
Yes.
It's this idea that if you are, in every game, there is this perfect unbeatable strategy in expectation. So if you're playing the Nash equilibrium, then in expectation your opponent can't beat you. And that's what the AI is trying to approximate.
So your work is combining game theory and reinforcement learning. You teach an AI just the rules of poker. Just here is how you navigate this game space, or here are the potential branches you can take in this game space. Traverse it however you like. Just you have to follow these rules, and then you give it a reward function, and you tell it to optimize that reward function. For example, how much money you make per hand, or how much money you make over a given session. Give some more color on how reinforcement learning works for Libratus.
Yeah, so you're using the term reward function, and in poker the reward function is very simple. It's how much money you make. So we give it the rules of the game. We say, if you bet this amount and your opponent called, and then you get to the river, the hand is over, and you have the better hands, then you win the money in the pot. So the reward function is very simple, and basically the AI is going to have a policy. It's going to have a strategy for every situation that it could be in. If the board is 2-3-5 and it has 3-5, and the sequence in the previous round it had bet $200 and the opponent called, that's a situation. It's defined by the actions that have occurred, that is the bets or the calls, and the cards that are in its hand and on the board. And for each of those decision points, it is going to update the strategy every time it plays. So every time it ends up in that situation, it is going to try something, and then it's going to see how much more profitable the other actions that it didn't take would have been. Mm-hmm. And in those cases where it was going to be more profitable by taking some other action, then it will choose that action more in the future. Now, one complication is that this process Poker is a very big game, especially no limit Texas Hold'em. I mean, we're talking about 10 to the 161 different decision points in the game that we're playing, which is more decision points than atoms in the universe. And really, you can make this arbitrarily large, right? I mean, we're talking. The reason why it's 10 to the 161 different decision points is because you have $20,000 in front of you in the game that we're playing, and you can bet any dollar amount between $100 and $20,000. So you have a branching factor of almost 20,000. But you can make that even larger if you allowed for let's say 10-cent increments of bets instead of $1 increments. You can make the game 10 to the 1,000 something. So really what we're dealing with here is a game of infinite size, effectively. And you can't come up with a good strategy for all those different situations you could be in. So what we do is we simplify the game a little bit. We say we're going to combine situations together. There really isn't that big of a difference between betting $500 and betting $501, for example. So instead of coming up with a policy that's unique for those two situations, we're going to come up with a single policy for both of them. And same thing with some of the poker hands, so there's very little. If you have ace high, it doesn't matter if you have ace high in your third kicker is a 2 or ace high in your third kicker is a 3. Those are essentially the same hand, and for the most part you can treat them identically. So you can simplify the game, come up with a policy just for those situations altogether instead of individually, and arrive at a good solution faster than you would have. Now, there is a problem here. If you're combining these poker hands, for example, then sometimes the difference between a kicker of 2 and a kicker of 3 is really important. When we get to the turn, the AI considers all of its poker hands uniquely for the first 2 betting rounds. There's 4 betting rounds in poker, in Texas Hold'em. So for the first 2 rounds, it's going to consider each hand individually. But when it gets to the third round, before it only had an estimate for how to play for the rest of the game. But when it's actually playing, it's going to recalculate its strategy and come up with a much better strategy for the situations that it could reach from that point on. And this is the endgame solver, the subgame solver, that took about up to 20 seconds to come up with its strategy during the play.
For more than 30 years, DNS has been one of the fundamental protocols of the internet. Yet, despite its accepted importance, it has never quite gotten the due that it deserves. But today's dynamic applications, hybrid clouds, and volatile internet demand that you rethink the strategic value and importance of your DNS choices. Oracle Dyn provides DNS that is as dynamic and intelligent as your applications. Dyn DNS gets your users to the right cloud service, the right CDN, or the right data center, using intelligent response to steer traffic based on business policies, as well as real-time internet conditions, like the security and the performance of the network path. Dyn maps all internet pathways every 24 seconds via more than 500 million trace routes. This is the equivalent of 7 light years of distance, or 1.7 billion times around the circumference of the Earth. With over 10 years of experience supporting the likes of Netflix, Twitter, Zappos, Etsy, and Salesforce, Dyn can scale to meet the demand of the largest web applications. Get started with a free 30-day trial for your application by going to dyn.com/sedaily. That's dyn.com/sedaily. After the free trial, Dyn's developer plans start at just $7 a month for world-class DNS. Rethink DNS. Go to dyn.com/sedaily to learn more and get your free trial of Dyn DNS. Interesting. So that makes a lot of sense because basically you're saying in the first 2 streets, before you even get to the flop, and then on the flop, the potential directions that a hand could go are just so multifarious. But once you get to the turn, like I remember when I was playing, a lot of the best players, they would really have their, and like you said, basically when you get to the turn, they would have like all these different plans mapped out for what can happen. Like if I do X on the turn, and then if the river comes this, here are all the different things I can do. Like here are the cards I can bluff on. Here are the cards where maybe I can make a bet of up to X and get X expected value. And here are all the cards where I can make a bluff. Like maybe on all of these cards I can make a really small bluff, and I can actually get a whole lot of fold equity despite it being a really small bluff. So like the turn in the river, there's so much more like really precise planning you can do relative to pre-flop and flop.
That's correct, yeah. You can come up with like a good, when the humans play, for example, when they're playing the pre-flop and the flop, they're not really thinking that hard. They just, make their decision instantaneously. They have a plan already. They have it planned out what they're going to do in every situation. And the AI is doing the same thing. It's already decided what it's going to do in all the situations that might come up on the pre-flop and the flop, the first 2 rounds. For the turn of the river, it has to think more carefully and analyze the exact situation that it's in. But for the pre-flop and the flop, it's only really like, coming up with an estimate, a reasonable, a sort of rough sketch of how things might play out on the turn of the river. And it turns out that in our experiments, that's actually all you need. You really only need that good estimate. And certainly your performance is going to depend on how good your estimate is, but we find that it gets very good performance, and the estimates it comes up with are very accurate.
That's so funny because, back when I played, there were all these people who would be successful with different styles, and the quote styles that they would have were often like different in terms of what is their pre-flop range, how much quote floating do they do on the flop. Like a float is where you take a turn where you just have like a backdoor flush draw, or you've got bottom pair or something really weak where you're just like, let's see what happens. Like the different styles were often articulated by that, but all of the players who were successful had extremely sophisticated turn and river play. So I think that falls in line with kind of what you're saying about the general truths of how you can build a poker AI.
Yeah, definitely. And I think that the strength of the AI is really its ability to play the turn and the river extremely well, far better than a human can. And there's some really advanced things that you can do on the turn and the river that most humans, on all streets, that the computer can do way better than humans. So for example, you might be familiar with blockers. It's this idea that, if there's 3 spades on the board and you have a spade, then your opponent can't have, and you have the ace of spades, let's say, then your opponent can't have the ace-high flush because you block that hand. And this plays a big part in a lot of bluffing, right? Because you want to bluff in situations where you have the ace of spades in that situation, because you can represent the ace-high flush knowing that your opponent can't have it. And the AI is really good at this, far better than any human. And it was one of the main strengths of the AI in the competition.
Really? Even in just no-limit hold'em?
Yeah, in no-limit Texas Hold'em, blockers, at the top level of play, blockers are very relevant, and really the difference between, beating the best in the world and beating recreational players.
Huh. Okay, because I knew blockers were like crucially important for PLO, but the Omaha.
Yeah, for Pot Limit Omaha, certainly for Pot Limit Omaha, it's more relevant. That's true, but for Texas Hold'em, when you talk to these top-level pros and you ask them, why are you making this decision? They're always thinking about blockers. That's what, tilts it from being a bluff hand to being a fold hand.
Right, and I guess a lot of these experiments that you were doing were deep-stacked also, right? And I guess in deep-stack, it matters a lot more, the blockers.
Yeah, definitely. If you're playing we're playing 200 big blinds deep.
Right. Okay.
Which is great because it's more challenging for the AI in a lot of respects because it makes the game much bigger. So many more possibilities that could come up. If we were playing, for example, 50 big blinds deep, then it's actually much easier to make an AI that's close to perfect. But with 200 big blinds deep, it was a real challenge. But it also allows for a really high level of really advanced strategic play. Because when you're in situations where there's so much money in the pot, there's far fewer hands that a person could have, right? If there's a raise and a re-raise and then another re-raise, then they're only going to do that with either a really, really good hand or a hand that could really represent very effectively being a really, really good hand. This blocker analysis becomes very relevant in those situations.
So we've been doing some shows around deep learning recently, and I'm starting to get a better understanding for this space. I think maybe a couple weeks ago I might have asked, why aren't you using deep learning? But I think more recently I'm starting to understand deep learning is really useful for building these like layers of abstraction for like collections of data that are really hard to understand. They're really deep and hard to not that term deep that I just used didn't have anything to do with deep learning, but a complex image is really hard to even understand. How do you parse this image? And so you build up these different layers of understanding the image. First you understand it at the pixel level, and then you understand it at the edge level, and then you understand it at the, some small unit level. But in poker, for example, the game is completely well-defined. It's just quite a different set of problems. So deep learning doesn't really apply to this sort of problem. Is that correct?
Well, we did not use deep learning in our AI. The focus of our research has been on reinforcement learning and trying to extend the results of reinforcement learning to imperfect information games. This has been a real challenge in AI going back for a long time. People knew how to make AIs for perfect information games like chess, and they sort of had an idea for how to do it for Go also. And in 2016, they really figured it out. But with poker, it had always remained this challenge because it's a fundamentally different kind of problem. And that's really what we address with our AI. We don't use deep learning with it. Now, that said, the methods that we're using are not incompatible with deep learning. You could throw in deep learning, and depending on how you implement it, it could help with some aspects of the AI. But, I think that it's not like there's a lot of different aspects to AI. Deep learning is one area, but there's a lot of others as well. And they're not all incompatible. And I think that deep learning has gotten a lot of attention in recent years, and for good reason, but it's certainly not the only area of AI. I think this competition and Libratus really highlights that you can see AI is advancing in a lot of different areas. And certainly reinforcement learning, which is what we're using, is a really quickly advancing field.
So one thing I can imagine is if you had two AIs that were competing to recognize images better, then for each AI, you've got all of these different variables that you can tune to make the best image recognition algorithm. And then you can use reinforcement learning to train the weights on those different variables. How would you apply deep learning and reinforcement learning together to a poker AI?
Well, I think one area where deep learning might be helpful, and again, we did not need deep learning to beat the top humans, but for imperfect information games in general, maybe other games, it could potentially help. I mentioned earlier that we combine some situations together. So, for example, if you have a bet of $500 and a bet of $501, we treat pretty much the same. And we do that when we're coming up with these estimates for how to play later on. We have techniques for how to do that, but alternatively, you could use something like deep learning to figure out how to combine those different situations together and simplify the game. And that might be an area where deep learning could be applied in the future.
Okay. Can you talk any more about what the implementation of that would look like?
I can't really comment too much because I haven't tried this.
Okay.
This is just speculation about what directions people might go in the future.
All right. Okay. So I was watching these videos of Libratus playing people, and it was funny to see these strategic manifestations that occurred because some of the stuff that Libratus does are things that people would explore at high-stakes poker, but they wouldn't explore them as thoroughly. Stuff, where really tiny bets or huge over bets. These things that people like Prahlad Friedman did, Stu Unger did this kind of stuff. People like, who was that really crazy high-stakes player? The guy that was dominating for a while. Anyway, well, I forgot his name. There's a lot of people like that. But, I felt like a lot of times they didn't really talk about the mathematical justification for it. Maybe they did have a mathematical justification and they just maybe they didn't understand it, or maybe they just didn't tell anybody because it was their secret sauce. But I think, today, probably the math of overbetting or underbetting is, maybe it's a little better understood. Can you talk about why Libratus makes these weird bets, why they're actually mathematically justified?
Yeah, this is one of the really cool things about the AI is that since it hadn't learned how to play from human data, it had learned by playing against itself, started from scratch. It was able to come up with these really innovative strategies that humans don't really employ, and the pros that we played against had a lot of trouble responding to. Now, as to why it chose to make these huge overbets, where it was betting 8 times the pot in some situations, I don't know what its thought process was. I mean, I'm not a pro poker player. I didn't tell it to do those things. I just gave it the rules of the game, and it played it after playing trillions of hands. It decided, hey, that seems to work out really well.
Did it do that on the turn or on the flop?
Oh yeah, it would do it. It would do it on the turn. It would sometimes do it on the flop. It was great, and the pros that we were playing against said that this is something that they really have to start using in the future, because it really allows you to grow the pot very effectively when you have a strong hand. And of course, you need to balance that, because you can't just do these huge overbets when you have a good hand, because then your opponent would always fold. You have to mix in bluffs as well. And I think that's a real challenge for humans. I think they're really afraid to make these huge overbets when they have a bluff, and understandably, right? I mean, humans don't want to. There's this aversion to betting $20,000 into a $200 pot when you have 3 high, right? So the AI obviously has no fear.
Well, what's funny is because if you start to do, it's almost like humans had this silent agreement just to not overbet before the river, because if you do that, the effect is that it increases the risk of ruin for everybody. Perhaps, I mean, maybe that's an overambitious statement there, but it seems like if you do that would happen, right? You would probably increase risk of ruin for everybody, and nobody wants that.
Yeah, honestly, the pros that we played against said the same thing. They said that when they're playing against other humans, there's sort of these unwritten rules that people just don't do certain things, and nobody really thought that it was that much of an improvement to actually do those things. It's just that they thought it just increased the variance, it increased the chance of losing tons of money, so they just never did it. And the AI disrespected all of those rules, and they really hated the AI for that.
So it was funny watching these pros. They were just like, by the end of it, they were just so exhausted and so like beaten down. They started doing this strategy. They're like, let's just 3-bet it 80% of the time. and
well, to be clear, they thought that was a good strategy. They analyzed the hands from the previous days, and they determined that, well, based on the data, they thought 3-betting 80% of the time was going to win them a lot of money, and it turns out they were very wrong. but they had a reason for it.
Did that just increase the velocity at which they lost money?
Basically, yeah. And
it's so funny that these two players coordinated still could not beat it. Although, I mean, I guess that makes sense, because Libratus is effectively an infinite number of, well, it's some number of robots that are collaborating with each other, just like comparing advice and stuff.
Yeah, so they were all actually playing against the same copy of the AI.
Oh, okay.
It was interesting. The AI was improving based on the play against the humans. So it was looking at what situations were the humans putting it in. And overnight, it would learn how to better respond to those situations. So it wasn't adjusting. When the media first heard about this, they immediately latched onto this as the AI adapting to the opponents and learning from the opponents and trying to figure out how to beat them. And that's actually not the case. The AI was looking at what situations the humans were putting it in and improving those situations to try to get closer to this perfect strategy, this unbeatable strategy. But the humans, they picked up on this, and they then decided to coordinate with each other, so that instead of using the same sizes and putting the AI in the same situations among all 4 of them, they would use different sizes. They would use different bet sizes, so that the AI would have harder time learning how to respond to all of them. So I got to hand it to the humans. They put up a huge fight. They put up an incredible fight, and they really gave it their all. I mean, they studied every night trying to figure out as a team how to take down this AI.
So they were playing the bot, and then the Libratus there's some offline batch learning that it would go through every night. Can you talk more about that, the cycle of learning?
Yeah, so the idea here is that on the first and second round, the AI considers a bunch of different sizes, a bunch of different bet sizes, both for itself and for the opponent. Like I said, there's 20,000 different possibilities, because you can bet any dollar amount between $100 and $20,000, but it doesn't consider all of them. It'll round, for example, a bet of $501 to a bet of $500. But, that's obviously not a perfect strategy. $501, a bet of 501 is different from a bet of 500. And the optimal strategy for those two situations is slightly different. So the AI would see what bet sizes were the humans actually using on the first and second round. And if they were frequently using similar sizes, like 525, 526, 527, something like that, and those sizes were far away from a size that it already had in its abstraction that I was already considering. Basically, if this rounding error was pretty large for the situations that the humans were putting it in, then it would learn overnight how to better respond to that situation in particular, rather than rounding it to the nearest size.
Can you explain how much of that was hard-coded and how much of that was like strategic algorithms that the AI learned?
This was all strategic algorithms that the AI learned. Very little of this is handcrafted. When it was deciding what actions to improve upon, for example, it used an algorithm to decide, well, these actions that the humans are using are far away from a size that I'm already considering, and they seem to be betting this this amount a lot, so I should really focus on this situation in particular to improve. Some things are handcrafted, and I think that this is an area for improvement. In particular, the sizes that the AI considers. It considers a bet. It might bet a quarter pot, or it might bet a half pot, or it might bet 1x pot. Those sizes were, for the most part, not entirely, but for the most part, were determined through a handcrafted choice. A human, basically myself and my advisor, decided on those sizes that it would consider, and then among those sizes, it would choose which ones to use. So that way, it didn't have to consider all 20,000 different sizes. It would only consider, maybe 10 different sizes to choose from. We do actually have an algorithm that can determine those sizes automatically. And I think in the future, it'd be really nice to use that instead. And we did use it to, for example, determine the first and the second bet sizes. So, for example, the algorithm determined that if the optimal opening bet size in heads up no limit Texas Hold'em is 0.75 times the pot, 2.5x, which coincidentally is something that humans are now using pretty frequently. So we used that size in the abstraction. But some other ones were handcrafted, yeah.
What programming languages and machine learning frameworks are you using?
The algorithms were written in C++. We used MPI to communicate between the nodes during the equilibrium finding process, basically the component where the AI is playing against itself over trillions of hands. We didn't do that on a single node. We actually distributed it over about 200 nodes on a supercomputer. And then the actual runtime agent that handles the communication between the human and the graphical user interface, all this stuff, that's written in Java.
I don't know anything about NPI. I feel like I've heard about that before. What is NPI?
MPI is a protocol. It's a framework for communicating, basically an API for communicating between nodes in a distributed process. You could think of it as a much faster version of TCP/IP, or like socket communication, for example, when you're running on a local cluster. And it's really low level. That's the key difference between this and a lot of other communication protocols. Is extremely low level. You're saying I want to send a message of this size, and the bytes are this, basically. So it's really fast. It's not robust to errors at all. You have to handle that on your own. But if you're doing something that's, each hand that the bot is playing takes milliseconds, a few milliseconds at most. So we have to have something that's extremely fast, and MPI is the right choice for that.
Artificial intelligence is dramatically evolving the way that our world works. And to make AI easier and faster, we need new kinds of hardware and software, which is why Intel acquired Nirvana Systems and its platform for deep learning. Intel Nirvana is hiring engineers to help develop a full stack for AI, from chip design to software frameworks. Go to softwareengineeringdaily.com/Intel to apply for an opening on the team. To learn more about the company, check out the interviews that I've conducted with its engineers. Those are also available at softwareengineeringdaily.com/Intel. Come build the future with Intel Nirvana. Go to softwareengineeringdaily.com/Intel to apply now. Okay, so help me understand how much of this is offline and how much of it is online. Because so when you have all the stuff that runs at night and is retraining the model, and then do you have just this model that sits in memory somewhere, or what kind of learning do you have to do even when Libratus is competing?
So if you look at the number of core hours that we use, the amount of computational time spent, the majority of it, about, I would say 60% of it, was spent online during the competition. Yeah, about 40% of it was spent before the competition doing this reinforcement learning against itself kind of thing, where it started completely from scratch and it played trillions of hands against itself and it learned a good strategy. And then, of course, it came up with a really, really good strategy only for the first 2 rounds and then estimated a strategy for the 3rd and the 4th round. And the 40% spent during the competition was mostly spent on coming up with a good strategy for those 3rd and 4th rounds in real time. And the amount of power that we're talking about is, somewhere in the ballpark of 20 million core hours. So this is not a cheap operation. We're running to train the AI, we use 200 nodes, each node having 28 cores. So that's a lot of power. And during the actual competition, we had 8 copies of the AI running. Each one used 50 nodes, and each node had 28 cores. Now that said, this technology is going to improve very quickly. This is where it is as of 3 months ago, but this was developed just by myself and my advisor. So if I had more time to code up the AI, we could get this running much faster. And I've told people this before, that I really think that within 5 years, you could see this kind of technology deployed on a smartphone and doing just as well, beating all the humans in the world at a game like Heads Up No Limit Texas Hold'em.
Speaking of deployment, how much of the players online are bots these days?
I don't know. I mean, I don't play online. I have never run this bot online or any other bot online. From what I've heard, the poker sites are very effective at cracking down on bots. They have a lot of security measures in place. So if they see, for example, that you've been playing for 24 hours straight, then they'll throw up a CAPTCHA that asks you, are you human? And they'll have like sophisticated techniques to trip up computer vision algorithms that might be trying to play automatically. Or they'll look at what programs are running on your computer. And in fact, I've even heard that if they really suspect you're a bot, let's say you won a really big hand, for example, they will call you up and ask you, what was your thought process during that hand? The reasoning being that if you're actually a human and you were in a huge pot, you're going to remember how you played that hand. But if you just had the bot deciding for you, then you're not going to remember the details necessarily. And certainly there's a huge risk to running an AI online. I mean, if they suspect that you're a bot, they're going to confiscate your money. That's the best case scenario, is that they confiscate your money. The worst case scenario is that you're doing this in a state where it's illegal and you actually go to prison. So, I mean, I think that there are bots online, certainly.
Yeah.
I have no idea how prevalent they are. I think it's going to become more of a problem in the future as this technology becomes more widespread. We're already seeing that there's a lot of tools for poker players in general, right? I mean, you have pre-flop tables, you have endgame solvers, all these things. And I think that once the research for Libratus gets out there and becomes more common in the poker community and better understood by the poker community, then these tools that humans are using are going to improve. And even if you're playing against a human, they're going to be assisted by an AI. It's essentially going to be like you're playing against an AI.
I think I would be more afraid to play on the 50-cent dollar no-limit tables today than the 510, because 50-cent dollar is probably like, people who have bots, they're running like 800 bots distributed along the 50-cent dollar tables. And then PokerStars is really focused on like the 510 tables for their anti-bot measures. I don't know, who knows?
Yeah, that's probably true. I mean, certainly the AIs that are... The AIs before Libratus, I mean, even like 2 years ago, they were able to beat at least 95, maybe even 99% of online poker players.
It's just not that hard of a problem.
It's not that hard to beat bad players. That's easy to do with an AI. You could even take a human that's like a pro poker player, and he could hand code some rules for how to play, and that would beat most of the players at the really low stakes, because there's just a lot of people out there that are willing to throw their money away for entertainment. But at the high stakes, then that's a different story. I mean, certainly before Libratus, just before 3 months ago, no AI was able to beat top players, people that really took it seriously.
So the reason I led off this conversation with a personal anecdote, I don't tend to do that in these shows, but the reason I do that is because poker, I had to leave the game because it was no longer a viable career to me. And for a while, that was really difficult because I was like, what am I going to do now? I focused my entire life on poker, and I'm sure through the Libratus project, you have met plenty of other poker players who that's all they do. It's like their life. It is their culture. It's everything they do, and they're going to have to abandon that because it's no longer going to be a viable career. I mean, it's been dying as a viable career for many years since the boom. The long-term implications for me were quite positive because I had to reinvent myself, and that was great. And I'm wondering what your take is on that, because all of these people are going to be automated out of things like truck driving in the near future, and it seems like this is actually an opportunity for tremendous reinvention along these people. But I mean, I also know a lot of poker players who have never reinvented themselves. They've just kind of languished in gambling, and now they're addicted, and it hasn't turned out well. But I don't know, I think you're in an interesting position to comment on the pros and cons of white-collar jobs being automated away.
Right, so I think you're bringing up 2 points. One is, automation of poker players, basically, and automation of other professions in general. With regards to poker, I think you're absolutely right that the poker boom has ended. It's never going to die. Poker's never going to die. But certainly we saw this effect where, It's like in any ecosystem where the smallest level of the food chain dies out, it's working its way up the chain, and the slightly larger fish are dying out of after that, the bigger fish die out. Eventually, the sharks are going to go hungry. And that's sort of what we're witnessing now. And it's certainly, I admit that developing AIs like these is not helping that situation. I think that it's going to hurt online poker, in particular, pretty hard. I still think that AIs are not going to be as widespread. This AI, for example, it plays heads up. The techniques could be extended. And the reason why we focus on heads up is because if you really want to figure out who's better, you really have to play heads up, because then you don't have any issues of collusion or interactions between other players. That said, the techniques could be extended to more than 2 players, and it would probably do just as well. So I think it'll be another year at least until this kind of technology really spreads out into 6 max and 9 max games. But eventually online poker is going to face serious problems. I still think that live poker at the casino is going to do well. And in fact, I think one of the reasons why we did this whole competition at the Rivers Casino in Pittsburgh, they were phenomenal, by the way. But I think one of the reasons why they were willing to host this kind of event is because it really highlights that, hey, you might not want to play on online poker tables anymore. You might want to come here instead, where you know that you're not playing against an AI. And for the people that are leaving poker, I really think that it's not a bad thing. Yeah, poker is fun, but I think it's something that you don't want to necessarily do for your whole life unless you're like at the absolute top of your game. It's very difficult to make a living and to make a whole life out of playing poker. This could be a very good opportunity for professional poker players who are not at the very top of their game to reinvent themselves, like you have done. Now, with regards to automation in general, automation of truck drivers and all these jobs, AI is sadly going to replace a lot of human jobs. Well, I say sadly. I mean, it's sad in one sense that a lot of people are going to lose their professions, but on the other hand, it's going to create a lot of opportunities as well. I say it's very similar to the Industrial Revolution. The Industrial Revolution removed a lot of jobs, but at the same time, it created a lot of opportunities and a lot of wealth for society. And I think it's important that we recognize that there is going to be winners and losers, and there's definitely going to be more winners than there are losers. But it's important to compensate the losers and make sure that they're not getting an unfair share of this advancement, that they're compensated for their loss by the winners in this automation process.
All right, I want to wrap up with one more question. So there's the Andrew Ng camp of thinking that general artificial intelligence is like overpopulation on Mars. Even though it's a tail risk, we shouldn't even worry about it right now. And then there's the camp of Elon, Bill Gates, Nick Bostrom, that artificial general intelligence threatens to turn us into paper clips. Are you afraid of artificial intelligence in any degree or any framing?
It's an interesting question. This is something that's it's sort of been delegated to science fiction for a long time, and I think that we're seeing such huge advancements in AI that maybe the time when an AI surpasses human intelligence is not as far off as we thought. That said, I still don't think that AIs are going to surpass human intelligence anytime soon. I think that this is not going to be a real practical concern for 50 or 100 years at least. Yes, we're seeing AIs beat humans at chess and Go and poker now, but you're still not seeing an AI writing a prize-winning novel. You're still not seeing an AI coming up with really cool and elegant mathematical theorems. So I think what we're seeing is that some things that we thought only humans were good at, we're actually seeing now that computers can handle those tasks as well. But there's still many more tasks that humans continue to excel at and that AIs are really, really bad at. And I think that we're just not really focusing on those because they're not as exciting. So I'm not terribly concerned about it in the near future. I think that we should be focused on how these advancements in AI are going to enrich our lives. Maybe one day we're going to have to worry about what intelligence really is. What does it mean to be an AI versus a human? But I think that's going to be a question for our grandchildren, not for us.
Okay, Noam. Well, I want to thank you for coming on Software Engineering Daily. It's been a fascinating conversation. I'm excited about Libratus.
Yeah, thank you for having me.
Indeed Prime is a sponsor of Software Engineering Daily, and they worked with us to create some tips for the hiring process. Today's tips are about hiring management. So if you're a hiring manager, I've got 7 tips that I think you might want to consider. These tips are sponsored by Indeed Prime, but I wrote them myself. Tip number 1, optimize for growth. If you are hiring people, you don't necessarily want to hire the person that is right now ready for the role that you're hiring for. That would be great, but oftentimes you can't find that, or hiring that person could be super expensive. Maybe take a risk on somebody. Take a risk on somebody who just graduated, who seems super hungry, and optimize for growth in the candidates that you look for. Tip number 2, hire for strength, not lack of weakness. Oftentimes, people have super exceptional strengths, but they've got a collection of weaknesses, like interpersonal skills, or maybe they're not great at writing unit tests. People can learn these things, or you can get those things from somebody else who has a strength in them. It's much harder to cultivate an extreme strength of a candidate. Tip number 3 is let a candidate propose a hiring procedure. So oftentimes the hiring procedures that are boilerplate that you can find online are not modern, and they don't let a candidate optimize for the things that they're great at. So why not give the candidate the opportunity to structure their hiring process? And if you say to them, hey, work with me to develop a hiring process just for you, if they can't do that, well, maybe you shouldn't even be hiring them in the first place. They should have enough creativity to say, okay, let me build you a side project that displays quality X, or let's do this structure of programming problems, and then they'll give you some ideas for programming problems they might want to work on, and then you can work on them together. I think these kinds of things can really show the best features of a candidate. So tip number 4 is give the candidate an opportunity to show strengths. So this really goes with tips number 2 and 3. You really want to give the candidate the opportunity to show their best side. And oftentimes these super limiting hiring processes like whiteboarding don't really let a candidate get creative and show their best side. So it makes people nervous when they don't get to, live in their own skin, when they have to live in this manufactured world of whiteboard problems. So tip number 5 is if you want servility, you can focus on servility and boilerplate programming problems. Sometimes it is good to have these whiteboarding problems because you have extremely well-formed problems in your engineering stack. Maybe you've got this very specific set of refactoring things that you need done. If that's the case, if that's what you're hiring for, then maybe you should do whiteboarding problems. Maybe you should have somebody find all the subsets of some collection of numbers that sum to 15. But I would say that it's generally better to hire creative engineers, and that's tip number 6. If you want creative engineers, focus on flexibility and creativity. That's why I'm suggesting that maybe you should even let the candidate propose their own hiring process, because if you present that to them, then an honest candidate will say, okay, I'm going to invent a hiring process on the fly that's going to test my creativity. It's going to present to you that I'm creative, and it's going to be fun for both of us. If that's too complex of a task for this engineer, then maybe they're not a great fit for a creative engineering role. But a lot of the hardest engineering roles take a great deal of creativity, they take a great deal of honesty, and they take a great deal of execution and communication skills. And I think the idea of flexibility and creativity in the hiring process, mirroring the way that the job will proceed, which will also be creative and challenging, it's a good way to set yourself up for a good relationship with that engineer if everything goes to plan. And the final rule number 7, or tip number 7, if you are hiring for boring legacy programming work, be honest about that. I know a lot of engineers, myself included, who have been kind of tricked into doing boring work. You get hired, you show up on day one, and you've gotten sold this really interesting project. Oh, you're going to build an anti-fraud system for analyzing all the transactions on our marketplace, and you show up and it's like, actually, you're refactoring this terrible legacy thing. This is actually a really common practice in engineering, and it's totally counterproductive. So there are people who want to do that kind of legacy refactoring work. In fact, we did an entire show about it with Andrea Goulet. Some people like doing legacy programming, and that's okay. And companies that hire for that kind of work should be honest about that. So this concludes my 7 tips for hiring managers, sponsored by Indeed Prime. If you want to support Software Engineering Daily and check out a new way for hiring, whether you're a hiring manager or an engineer, go to Indeed.com/SEDaily. Thanks again, Indeed.